In this video, we're talking about method overloading, and we're going to look at some examples in the ArrayList class. So we're going to start out today just reviewing some information about ArrayLists. Our goals today are to review that information about ArrayLists and also understand that a single class can contain multiple methods with the same name. So we've talked about ArrayLists before. We know that there's lots of different projects in computer science where you need to store a collection of items in a list, and that one way we can do that is with a standard array. But Java also has this special data type that's designed specifically for lists, and it includes a lot of helpful methods that we can use to process our lists, and that data type is called the ArrayList. It's one of the classes or data types that's part of the Java standard library. We've talked about ArrayLists before, so you probably remember that they store a linear collection of like-typed items. That just means that you could line all of the items up and that all of the data in the ArrayList represents the same kind of thing. We group them together with a single identifier, and that is used to reference the whole collection. So for example, we could have a list where everything included in the list represented a quiz score, and that might have a double data type. Or we might create a list where everything in the list represents somebody's name, and that would be a string data type. Each of the individual values in the array list is called an element, just like it is in a standard array. And again, the data type in an array list has to be a reference type. It can't be an integer value. That sounds like a big limitation, but it's really not, because all of the primitive data types like int and char and double and boolean have a reference data type equivalent. And so it's no trouble for Java to store a collection of integers. It's almost indistinguishable to you, the programmer, from an array of ints in terms of like how easy it is to set up. We've looked at the syntax for declaring array lists in the past. That always looks like this, where you have the name of the data type array list, then you have angle brackets, and in there you include the reference data type that you want to store in all the individual boxes of the array list. Then you pick an identifier for your list, say it equals a new array list. That's allocating the space for this collection. You give it the data type that you're going to store inside it once again, and then parentheses to close it out. So for example, if you wanted to store a list of quiz score values and they were doubles, you would type in ArrayList, the data type, and then include the angle brackets, and then put the data type double in there. Pick whatever name you want for your quiz score list, and then say it equals a new array list with that data type and angle brackets again, followed by parentheses. It's kind of strange syntax, and we're going to talk more about what all of that means next week when we start talking about object-oriented programming. If we wanted to store an array list that had a collection of last names, it might look like this: array list, and then angle bracket string, name list, or whatever you want to call it. You could call it whatever you want, equals new array list string with parentheses. So I think you get the idea of how to declare array lists. And remember, there's a lot of specialized operations that are defined for array lists. For example, there's a method that lets you add values to the collection. Once you have an array list created, you can add a value by calling the add method. And if you look it up in the API, it's kind of interesting. Look how there's two different methods here. So they're both called add, but they have different descriptions. This one says it appends a specific element to the end of the list. This one says it inserts the specific element at a specific position. So they have different meanings. They do different things, but both of them have the same identifier associated with them. So in your notes, it asks you to summarize the difference between the two methods in terms of expected arguments. So what do you think? What's the difference between the two add methods based on the expected argument? So remember that the expected argument matches up with the parameters in the parameter list. And so this particular version of the add method, it expects one argument to match with this one parameter, and it looks like it represents a kind of like a generic data type. It's just represented by E, an element. Whereas the second method, it takes two parameters, so we would need two arguments. The first one's an index, and the second one is an element. So I'm going to write in that the first version requires one argument when we call it the element to add, and the second version requires two arguments, the index and the element to add. So what's the difference between the two different versions of the method in terms of purpose? So again, just think about that based on the description here. You can write it up in your own words. I would say the first one, the second one allows you to choose the position where you want to add the new element, but the first just adds it to the end of the list. Again, you can put that in your own words, whatever makes sense to you to describe the difference between the two different versions of the add method. What's the difference between the two versions in terms of return type? So this first one returns a Boolean. Remember, the return type's always out here to the left. And the second one has no return value, it's void. So it's kind of interesting that ArrayList class has these two different methods in an add. They have different purposes, they take different numbers of arguments, they have different expected return values. And so you might wonder, how does Java figure out which one you're trying to call in a specific situation? We'll be talking about that next.